Okay, introduction to Node.js. So Node.js is an open source cross-platform JavaScript runtime environment. It executes JavaScript code outside of a web browser. So in terms of nerd level, this is one of the best invention the past 10 years plus. So back then we had to deal with language like Ruby, Python, PHP, or even Java to build a backend for websites or apps. Now it's all possible with Node.js. So Node.js is an event-driven, non-blocking I/O model. So it's very efficient, very scalable for real-time applications such as chat applications or online games. And it also has a very large and active community, which contributes to its growth. So back then, when it started, the community starts to grow larger and larger. And now we have a lot of tools to make development easier. For example, we have Web3. Recently, we have Web3, and the community was quite fast adopting the standards. We have machine learning as well. We have adapter from the machine learning model to JavaScript. I think you can also train AI model with JavaScript nowadays, if I'm not mistaken. So Node.js is widely used by companies like Netflix, Walmart, PayPal. I've used it a lot in the past, and it is very, very fast. We've had servers that is very CPU intensive and very memory intensive from our previous project. But when we moved it to Node.js, we just require a very small server to handle requests. So it started in 2009. So back then, JavaScript was only used on the browser, just as a simple interaction between the user and the browser. For example, clicking a button would change something on your screen, or it would do something like any simple animations that you can do. But now JavaScript can also run on the server. So there is a difference with Node.js on the server and JavaScript on the browser. On the browser, there is a set of tools that only browser can run. If you have ever tried the console on browser before, you can access window on window.console log maybe on your console, but on the server, you would have something like a global. And most of the packages that you see on NPM, it cannot be run on the browser, and some cannot be run on the server. For example, if it involves like low-level integration with other language. Okay, so here's what Node.js can do. And they can do this very, very well. We have data streaming, server-side proxy, big data and analytics, wireless connectivity, system monitoring dashboard. This one is quite common. Real-time data. This one is also quite common, but mostly used with user-centric or even data analytics. Queued I/O inputs, chatbots. Chatbots have very fast response time for this one. Web scraping, and then REST API. So we'll be focusing on this one for the entire session, and even during part 2 and part 3. So this is what Node.js looks like when you're building REST API. This is just a basic example with Node.js. And this is using Express, if I'm not mistaken. So Express is a web framework that you can use to build REST endpoints. So we have declared that we need to access HTTP, and we created a server with this hostname and port, and we would return hello world when this server is hit. So for example, you have 127.0.0.1, that would be equivalent to a local host. When you hit the first page of that local host, the endpoint would return you hello world. And then the server would listen to this port and host name here. So Node.js is event driven. What that means is that most of the time Node.js will be listening to something and it would trigger a callback function, which is this part, the third parameter here. It will trigger the function and run that function once it's triggered. So when you use Node.js, a callback is fired, but if there is no work to be done, Node.js will sleep. So it's quite efficient. So in contrast to today's common concurrency model, the OS threads are just a simple loop. So there's no deadlocking, there's no, because there's no logs. So no function in Node.js is directly performing IO or process that blocks the Node.js like synchronously. You can do that, but you would have to specify it. Okay, so this is the important concepts in Node.js. So in any framework or programming language that you learn, you have to understand the foundation of the idea or the concept that the framework is trying to solve. So what Node.js is doing right now is it has a very basic event loop to kind of manage everything inside the program. So it's first in, first out for all the functions and triggers inside the event loop. So we have the timers here. It executes any callbacks scheduled by set timeout and set interval. And then we have the pending callbacks that executes any IO callbacks that is deferred to the next loop. We have idle and prepare. The one is mostly internal to Node.js. We have polling. We get new events, new execute callbacks, and then we kind of trigger anything else that is directly inside the poll with by getting triggers from the data. Then we check, we have set immediate callbacks invoked here, and then we have a close callback. So something like if you're done with listening to something, you can do a close callbacks here. And then it would repeat each time the Node.js is running. You may think the event loop is slow, but with Node.js, it's actually quite fast. And there are concepts that you need to learn in JavaScript, such as promise, asynchronous calls. It would be a first in, first out inside the event loop. So let's say you're calling something from the API, and at the same time, you're also calling something from the assets folder. It will queue inside the event loop and run one by one. First, it would trigger the API. If it's done, it will trigger the API callback. And then if the accessing the image is done, it will trigger the callback for accessing the asset. Okay, so another concept that you would need to know with Node.js is that it is mainly event-driven programming. So different with traditional programming where you run things one by one, like the one at the bottom. Event-driven programming is creating a listener and calling the callback. So when doing your interview, interviewers would sometimes ask, are you familiar with event-driven programming? This is because companies that use Node.js, they will always ask about this. They will always ask about how you've used event-driven programming, or even how you've used event-driven architecture. So this would be important during interview when you answer these questions. So again, you create a listener to read this file, and then once the program read that file, grab and read that file, it will run this. So if I were to do multiple of these read file functions, then it would kind of see which file would finish first and then trigger the callback. So unlike EDD, this one will trigger procedurally. If you've used C, C++ before, you are more familiar with this one. But if I were to run the whole program, it won't trigger this first. It won't trigger console log first because we're waiting to read file txt. It will trigger all these four first, and then it's gonna wait until the next loop to see if file txt has been properly read. So that's event-driven programming. So Node.js layered architecture. Usually you would have multiple layers of stuff. You have the presentation layer. That would be your Vue.js, React.js, or even your mobile app with Flutter, React Native, or even native iOS and Android. And then you have your router layer, which is your gateway to your API, or even your API server itself. And then you have your service layer. So this three part would be usually in a server if it is a monolithic server. So your service layer would have your business logic, and then your data access layer with your database. So some of the Nest.js framework out there right now, some of the Node.js framework out there right now, they have properly give you an opinionated sections for you to do. You have your router layer defined with controller, your service layer with services, and then your data access layer with repository. So is there anyone that has used Laravel or Ruby on Rails before? So that would be the same as this one. You have your controller, your model, as well as your logics, and then your view. So kind of an MVC, but Node.js, there are multiple ways to approach this. Okay. All right. Okay. For interviews, you would probably need to know the most basic architecture. So this is the most basic architecture. Most of us use this even with our own local setup. We have our presentation layer, like I've said just now. Usually front-end developer would be doing this. And then we have the back-end developer. Let's say you're using Express and Mongoose to kind of fetch and query your MongoDB. So this is monolithic, and it's the most basic one. It's also showing the most basic relationship of client server. And then we have serverless architecture, where you have your clients, but then it's not exactly directly accessing your API or directly accessing your server. It can be broken up to multiple instances of server, depending on the services that you've used. So for example, you have Firebase or even Vercel to help you with this. So you would have your front-end logic, and then your back-end logic, your security, and database. So in terms of Firebase, the database would be Firestore. Your backend logic would be stored in Firebase functions. And then for security, it would be Firebase rules. And for authentication, it would be for Firebase authentication. So Firebase is free. You can try it out if possible. And you can do a lot of things with Firebase. So for backend logic, what happens is that for each functions that you create, it would have a very specific instance that will run it. So let's say you upload 3 functions, one function for hello world, one function to calculate 2 values, and one function to fetch from the database. So for every time someone call that function or someone called the endpoint, a new server instance is created for that function, and they would access it directly from the instance. So why is this a good thing? First, you don't need to think about scalability. If you were to go from 10 users to 1 million users in 1 week, that would happen very automatically. and you won't have to face any kind of bottlenecks with performance. It'll be very fast for everyone equally. But the downside is serverless is very, very expensive. For every time you call a function, it is calculated against how many minutes you've run your functions or how many calls you have run towards your functions. Okay, and then this one, I doubt that interviewers will ask you this, because for fresh grads or juniors, when they enter a new company, microservices is the less exposed architecture that we deal with day to day. Even for your assignments, I don't think you will face this, because it would take a very high group effort to create something like this. So you would have your mobile app, and then you would have your browser. It goes through an API gateway, and then it would call each server with different database in it. So let's say an account service would have an account DB, an inventory service would have an inventory DB, and then we have with shipping service, we have shipping DB. So how does this alleviate the pain points of maintaining servers? So let's say you have a service that keep tracks of shippings, and your users are using it quite a lot, to the point that other users find it very, very slow to access them. So what happens is that with the shipping service, instead of using one instance of server with shipping service, we deploy multiple server for that shipping service, and then route them through the API gateway. What would happen is that the mobile apps would request from any instances of the shipping service with low loads, and then it would work fast as it would normally do. Other examples that we can apply this to would be something like a ticketing system. Let's say you want to buy a ticket for a concert, but the website is slow. So what the developers can do is that they can do something like microservices so that it doesn't block other users from using the system. And the most famous and the most I'm intrigued with the architecture would be Netflix. So have you ever encountered slow buffering on Netflix? It would make more sense from ISP to be the problem one. Your probably Unify, Time, Cellcom, DG, Maxis, they're the problem. Maybe, I'm not sure. But most of the time, Netflix architecture is very robust, and everyone wants to be Netflix, but not everyone should be Netflix. So again, they have elastic load balancer to check which service is free. And then they have API gateway service. And then they have multiple microservices, just like the one I've shown you just now. They have specific API for discovery, specific API for play. So all of these work together within multiple microservice and multiple data store to give the best kind of performance and the best kind of experience to users. And then for Netflix particularly, they have implemented this thing called chaos engineering. So what chaos engineering is that it's the discipline of experimenting on a system in order to build confidence in a system's capability to withstand turbulent conditions in production. So what this means is that Netflix intentionally will bring down their server or their services, and they would check, will that service revive by itself? And that's a pretty fascinating thing to do in your company, since if one service were to be down, people would probably be pissed when they have to stop halfway of watching a movie, for example. Microservices architecture is also used in other companies, but the one I have most respect is Netflix. And they have created a tool called Chaos Monkey. And what Chaos Monkey does is that it randomly terminates an instance in production to make sure that engineers have implemented their services properly and for the architecture to be very resilient to instance failures. So as a back-end developer, these are the stuff that you will be exposing towards your career journey. You would first be exposed with mostly on programming, and then you would be understanding how the architecture of your system works in your company. And then you would probably be able to be having a little bit hands-on on DevOps as well. So depending on the company, back-end developer are also usually DevOps. But for big companies, those roles are very separate. You would have to, they would have to have a specific role for DevOps and then specific roles for back-end. It keeps the team focused and each one has their own responsibility of their kind of what they own or their ownership. Okay, next we would be moving towards our back-end framework. So we have multiples. We have quite a lot of back-end framework that we can use in Node.js. So the first one would be Express. This one would be the simplest one to work with. It's very minimal, very flexible, and it's very light. So if you're doing something simple or you want to do something fast, you can use Express for this. You can create a RESTful API and handle HTTP requests with this one. And then Nest, this one is Nest. It's spelled N-E-S-T, or in BM we would call it Sarang. It's a framework on top of Express, but it is very opinionated. It has its own, it connects to an ORM that kind of lessens the query, writing query to the database. So you won't have to do something like select all from table user, something like that. You would have to deal with type ORM instead. It would have separation of concerns in its framework. You would have your services, you would have your controllers. And then next we have Happy. So it's an open source Node.js framework as well. Much like Express, it's quite simple. For sales, and for Sales.js, it's an MVC web application framework. So it's almost identical to Laravel and Ruby on Rails. The next one would be documentation. So we have Swagger for documentation. For some framework, it's included directly, and you can just give it a sort of metadata, and it will help to generate the Swagger documentation. So back to the Marvel's API, we have the public documentation that they've built, but at the same time, you can also do this for your internal team, where you create your Swagger API, and then your other team members can access and read it properly. So like this one, we have v1/public characters, and it will tell us what it does. So right now, this one fetched a list of characters. Okay, that's quite straightforward. But the best thing about Swagger is that you would have the nodes, you would have the response class, and you kind of can just create this class inside your, maybe your JavaScript program, if you're using TypeScript, or even something else like Flutter, which still use object-oriented for it. And then from here, you can try to check, to try to test the API itself. You can pass the parameter here, the limit and offset, and then it explains to you the status codes. So right now I've tried to call for a default call, and it gives me this response body. So let's try another one. And let's try with N, since N-Man is going to come out soon. So is there anyone will be watching it when it comes out? Okay, So we have N-Man here, Eric O'Grady, no idea who that is. And then we have all kinds of data from Marvel regarding this endpoint. And it'll be in JSON form and only in JSON form. So there is no XML support for this REST API